record here. All right, so please, if you're not hearing me, just type in the chat, sir, get my attention. All right, because it's really hard to go over it again because we don't have much time and we want to go through the other labs, right? So we have our graph paper here, right? Let's just say, remember, yes, I remember it now, right? I have a better I think I remember it a little better now. How the values were, right? You had 0.1, 0.2, 0.3, 0.4 going down, right? So then on your graph for weight, weight is in the x-axis, extension is in, extension is in the y-axis. So weight is in the x-axis, or load, weight or load, and extension let's move this quickly. Move this down here. Yeah, come out of the way, please. All right, so we have weight in the x-axis and extension in the y-axis. Extension, right? So you would have, I want to see weight, something like this, and extension. You can write it sideways, right? You can write it sideways. I think I can do that. No, I can't. I am not able to write it sideways, right? And if your values are 0.1 as suggested in your values, 0.1, then you have 0.2, then you have 0.3, then you have 0.4 going down. Let's go to 0.6, 0.6, 0.7, right? No.
To where it stops, sir?
Yeah, so wherever it stops at 0.7, I think that's what Tyree said. It didn't go up to 0.75. So you will change. I didn't know that.
0.65.
Yeah, you change this to 0.65, right? 0.65. After you plot a graph, let's say the first value is 5 centimeters. Extension, you would have your normal length and your stretch length. You minus these two. You find the difference between these two, right? I think you want to take a picture of this when I'm finished, right? You have 5 centimeters, 10 centimeters, 15 centimeters, 20 centimeters, I don't know the exact values, and then 25, right? Then you'd have 5, 10, 15, 20, 25, right? And you have your graph here. You go to 0.65 for this particular question, which is in the middle, 0.6, and you have 0.7, right? You have 0.6 and 0.7. Of course, 0.65 will be in the middle. So you use your ruler, go up to the line, and then go across to the particular value. And I believe this is 20. So your answer for this will be 20 centimeters. All clear?
Okay, yes, sir.
Is that better now, Mr. Noble?
Yes, sir. Yes, sir.
All right, so take a picture of this, please. Take a picture.
Okay.
I'm giving you 5 seconds to take a picture. We need to move on to the next one before the time is up. We have 15 minutes. All right.
Okay,
So I'll
sir.
move on now. You can share the picture in the group. Anybody take a picture?
Wait, sir.
This, sir.
Yeah, does somebody just take a picture of it just to help? Anybody take a picture yet?
Yes, sir. I'm
All right, so share
screenshotting.
it in the group. All right. Yeah, you can also screenshot. All right. Move on to the next one. All right. So let me get rid of this off the page.
But let me see, I put 0.1, 0.2, 0.
Yeah, on your
Yeah,
x-axis.
you have 1, 2, 3, 4, 5, 6, 7 to sir.
Is an example, you know?
Oh, okay.
I'm not sure what happened here. Okay. And let's get back. All right, so no graph for this one, right? Was there any misconceptions here in the question?
density. The things that
Density of number 4 million into that.
Based on the experiment, what was the density affected by a mass, the volume, or neither? Explain your answer. So what would the answer be?
Yes, because
Yeah.
one
So yeah, that's good. All right. So no problems in this then. Any problems? All right. I'll take that as a no. All right. Please stop me if you're having a problem. Next one, center of gravity. Were there any misconceptions here?
kind
Was there any misconceptions? Yes or no?
Sir, for 4 and 5, the way we did set it on the nail while we did find the middle height, center
All right.
gravity.
When was the irregular lamina unbalanced?
sure me right when me place it on the bag string nail.
All right. So when you placed it on the pin, right? Remember that we kind of make it settle a little bit, right?
Still
Yeah.
never.
So it wasn't lean. We had to kind of move it a little bit to find where it was balanced or to find where it was stable. You remember that?
So when the lines are meet at that time, it said balance.
All right,
When we
so
find the center,
I see that D 4 and 5 are the same questions. All right, 4 and 5 and 7 and 8 and 9 are the same questions. Yeah, so
pressure.
yeah, we only do number 6.
all right. Question?
Yeah, the group you said that the questions are just like can use some of them then.
You're breaking up.
You said that in the group that the questions are just a guide, sir.
The questions are what?
Just a guide for the discussion, so we don't have to use them. But
Yeah.
That in the group, sir.
Yeah, yeah. So you don't the questions that you're not really able to explain or to answer, right? Is you can omit some of these questions or the ones that don't make any sense because also this was done in probably 2 nights. The 20 labs are out of 20 out of 20 lab instructions in 2 nights, which is not I don't recommend for anyone. So that was crazy. I don't think I slept that night. So some of the questions might not make any sense, right? I did this in like 2 nights, so I didn't sleep. I was up the whole night doing this because I wanted to get it to you before your lab. So some of the questions might not make any sense, but the ones that you can answer, of course, answer the center of gravity, define center of gravity, the significance of the center of gravity. We discussed this in class. Where does the center of gravity act for a regular object, right? For these questions, just talk about the fact that you, before you carried out the experiment, you swung the lamina. The lamina is this cardboard here. This is our lamina.
Yes, sir. Back to the one what I graph, sir.
Back to the graph.
Yeah, this one, right, sir. Could we start at 0.3 and then 0.5, then 0.7?
Anything with the pie you're sitting.
But look, you're not listening, you're not hearing me. I say, if you don't have bottom, oh my God, bro. You cannot see my right hand.
All right, you want to send me a picture? Sorry.
All right, sir.
Close the classroom. I will do some work inside. All right. Okay. You want to come now? All right, I'm gonna have to go pack up there. And can ask him to give me 10 minutes? Sir? Ask him for 10 minutes, please. All right. Yeah, sorry about
Lab 4 now, sir. Skip.
lab 4. Yeah.
Yeah.
All right. Yeah. Hopefully. All right. So Tyrese, send me a picture. All right. Tyrese.
Yes, sir. Yes, sir.
Yeah, send me a picture. All right.
Yeah.
All
Right now,
right.
sir.
Good. Send me after the class, and then we'll discuss it in the group after. All right.
All right, sir.
Yeah, we have 8 minutes. Let's see what. All right. So you're not doing pendulums yet. I'm saving that one for next year. All right. Then we talk about radioactivity, radioactive decay, right? And we see this popping up again, right? Construct a graph showing undecayed nuclei against the number of throws. Which one on the x-axis?
When I get this, I want to answer.
Number
Get
no,
this.
on x-axis.
Oh
The
yeah,
decay one, the decay.
yeah.
Because
Forgive me.
we never see that.
Forgive me. Yeah. So the problem for this was that yeah. All right. The problem was for this was that there were not enough dices or dice. My apologies. There were not enough dice for everyone, so we had to skip this one. This one would be easier than the beard. All right. All right. Let's move to the next one. I'll go back. Forget lab 6. Forget this over here. Don't pay attention to this. But now we're looking at power. Whenever I can find, where is that document? Because I don't want to confuse you.
Stones melt my burn.
Please give me a moment, guys. All right. So lab experiments. Okay. Here we go. I believe it's this one. Right. All right. Please be patient with Mr. Treasure, right? Yes, this is it. All right. Okay, lab 3. Right, lab 4. Okay. All right. So this look familiar, right?
Yes, sir.
All right. So we see this popping up again, right? Plot a graph of volume against time. We're trying to go on the y-axis.
So you want to write the result them on the graph.
Go again.
Volume of
I heard a question.
time. Sir, time.
If
Dog up on the
volume,
x. Sir.
if volume go on the Y, sir.
I am not hearing. We should go on
Volume
the
go on the Y.
volume, go on the y, right? Volume on the y, and this go on the x, right? Okay. I heard another question. What was the question? Please tell me.
No question, sir. I say for number 5 things. I did the graph. I did the table. I did the graph.
Okay. No problem. All right. So yeah, we have our graph paper, and we now have to look. So this volume, I didn't get to explain this to everyone in the class because I explained it to the first 2 groups that came, but we had some students who came like really late. So I didn't get the chance. I wanted to complete the next lab. So I didn't get the chance to fully explain this. This volume is the amount of volume that is left in the burette. Let me repeat that. This volume here, this particular volume, is the amount of volume that is left in our burette. So we had our burette, right? Had our burette, and it was up here. How much time we have left?
Sir, may I say something? If 50 die bottom or die top, can you really remember?
Yeah, so we start at 0. So at 0 seconds, there was 50 left in our burette. 50 milliliters left in our burette. At
That means
say 2 seconds afterwards, there was 45 left in our burette. At 8 seconds, whatever, I don't know the exact values. At 40, there was 8. At 8 seconds, there were 40 milliliters left in our burette. So that continues down, and our burette is continuously dripping. So we'll draw a graph looking something like this. Our graph should look going in this way, right? Something like this. All right, I want to see the graphs.
An example, right, sir?
Go again?
An example.
Yeah, this is
Sir,
just an example.
we
This
got
is to record the times that time it took to reach to the 5 mark.
Right. So that is that time you would put it here. So the time it takes, we reach from 50 to 45. The time it takes to fall down. We understanding? Are we all clear?
Yes, sir.
Yeah, but I'm sorry I can mistake then, sir. Because we start from 5 during the lab, we start at 5, you know.
Yeah.
I call 55 then.
Right. And I sent a message in the group saying that I think Mr. Noble's group, you're in Mr. Noble's group, right?
Yeah.
Yeah. So send me your results as well. So I have 2 things to send me, Tyrese. I have 2 things to send me.
No,
Send me a
no.
quick.
No, I'm not Noble's group, sir. I'm
guys in the group by himself, Mark and
me and Mark and Malvern.
All right. So send me if you don't have anything like this starting at 0, send me results. That's what I'm trying to say. Send me results and we'll discuss it. All right. So we say
Sir,
time
sir,
in question.
me never do this lab, sir.
Or you came late.
Yes, sir.
All right. So get the results. That's just how it is, right? You weren't even supposed to be in school doing labs, right? At that time, you were supposed to carry a registration. So we not. If we try and do it over again, we can get in trouble for it. Serious trouble from the government. So get the results from somebody.
Alright, sir.
All right. So after Tyrese,
But you
after
have a
me,
lab book, sir.
go again.
May carry is up
Yes,
there
I
already.
understand you're carrying the draft book. That's why it is a draft book and not the final thing. So when they
Alright,
get
sir.
back the actual thing, I want to see a discussion and I want to see a method, right? You can do the results afterwards. You can sort out the results afterwards. All right. Any more questions before we move on?
Alright,
We
sir.
have
Move on.
all right. We have 1 minute left. uh, all right. This was easy. All right. Any questions here? In a
No, sir.
discussion, let me take off these foolishness off the place. Right? Any questions here in the discussion? What is physics? What effect does mass have on power?
Time on the X, sir, and
No, there's no graph here.
no, on the last one. It was
really get this one.
Yeah, graph time on the X and number of and volume on the right on the Y. Sorry. Right. All right. Then then we had moments. We'll have to discuss Snell's law again tomorrow. Yeah, we're out of time. We're out of time. We'll have to discuss Snell's law tomorrow. All right. So we'll have to look at this as well. All right. All the best. Tomorrow meet again.
Alright, sir.